Okay, welcome back to Grade 9 Science Explorations. We're going to look at a really quick topic right now, and a lot of it's going to be review for many of you, I hope. We're going to look at food chains and energy within an ecosystem. So what is the take-home message here today is that energy flows through an ecosystem, and matter is recycled within an ecosystem. So if we look at these notes, almost all the energy that we have within an ecosystem comes from the sun. A very little bit will come from the center of the earth and the heat that comes from there. There are ecosystems that appear to be almost completely dependent on hot vents in the center of the Atlantic Ocean, but those are very rare ecosystems. Energy flows through an ecosystem, and most of the energy is lost from the ecosystem as heat. Matter is recycled within the biosphere, unlike energy, so there's a recycling of matter. Matter is reused. The matter in your body has likely been in another organism's body before, especially because you ate something that was once alive. And so matter is always being recycled. So we map the flow of matter and energy within an ecosystem with a food chain. So if we look at a very simple food chain that you might find at a local ecosystem, we might have a plant, okay? And that plant is capturing sunlight, and so we call this plant a producer. And that plant captures sunlight, and it brings in carbon dioxide and changes it into sugars, which organisms consume, such as a grasshopper. And so we have here a grasshopper that eats the dandelion, and the grasshopper is then eaten by the frog, and the frog is then eaten by the snake. And you can imagine that I could even continue this, maybe even one more level, and we could maybe put down a hawk here, and that hawk could eat the snake. Although getting more than 4 organisms in a row eating each other above the producer becomes quite rare. And let's look at why that is such a rare situation. So if we actually look at what is going on in our food chain, you can see down here at the bottom, I've ordered it a little bit differently. We have our dandelion, and any of those plants we'll consider to be producers. And we say that a producer is autotrophic, which means it's self-feeding. We covered that in an earlier lesson as well. And we also have up here the other organisms that are heterotrophic, which means they depend on other organisms for their matter and energy. So we have the flow of matter and energy like this, and we can label these based on their trophic level. So we have a producer, and then our grasshopper is our primary consumer, our frog is our secondary consumer, and our snake is our tertiary consumer. But what I really want to note here is that the energy in a food chain, 90% of the energy is lost between trophic levels as heat. So as we move from the dandelion to the grasshopper, if we started with, I'm going to make a number up here, 1,000 kilojoules of energy in a unit of whatever is being eaten, then 90% of that, or 900 kilojoules, is lost as heat, and only 100 kilojoules of energy is available to go into the grasshopper. And then you can see the same thing will happen with the snake, and so we will lose 90 kilojoules of energy in that trophic level transfer as heat, as the grasshopper has to grow and reproduce and jump and all those metabolic issues that a grasshopper needs to keep itself alive burns energy, and we lose that. And so we end up with only 10 kilojoules of energy within the frog. And if we transfer that on to the snake again, we will lose 9 kilojoules of energy. And there should be a unit, a per mass of the organism, but this is simplified a little bit. And that snake will only then acquire 1 kilojoule of energy per unit of frog that it consumes. And you can see why it becomes very difficult to get anything above a tertiary consumer. So if we had a hawk eat that snake, you can see that that hawk would get very little energy per unit of mass. And we would call this level a quaternary trophic level, or quaternary consumer. Okay. One thing that is sometimes missed is the fact that all the matter that each of these trophic levels contains ends up going, after the organism dies or is consumed, to decomposers. And decomposers will in some way return some of those nutrients to the dandelions or the autotrophic organisms in the form of soil, and return that organic matter to the system, so it allows for recycling within the system.